Hello, student. Precalculus, Chapter 2, Section 2. Polynomial and rational functions. Polynomial functions of a higher degree. Okay, we've been talking about line, which is the first degree, parabola, which is the second degree. Then higher degrees like cubic function, order of 3, like has x cube in it, or fourth degree or fifth degree. Graph of polynomial functions. Well, functions, they are normally continuous with smooth corners. Continuous, as you see in this graph, and with a smooth rounded corner. If it does not have a smooth rounded, it's not really truly a function. Sometimes it could be continuous with one break. You can say is continuous except one value. So again, it function has smooth, rounded turns. Well, this function absolute x not truly a function because it have a sharp corners, is not smooth. The basics, like we saw that in the parent functions, the basic higher order functions, fx equal x to power n, where n equal 1, 2, 3, 4, etc. Could be any number. See this function here on the left, you can see that the x square function, the shaded gray, it have the lower is a little bit sharper rounded corner. When you have a higher orders like x to power 4, it get a little bit flatter at the bottom. Well, it's not really flat. It's kind of, it's still round, but almost flat. So because it's, we cannot draw it with a curve, it's going to look like a flat. Same thing, this is for the even power. For the odd power, the x cube, same thing. You can see the shaded gray graph x cube comparing to the x to power 5 higher order also get flatter at the origin. So still it really is not flat. In reality, is rounded, but because a higher order, it make it look like flat. So this is for the odd numbers, odd power. Most odd power look like this, and most even number look like that. They're gonna get more complicated with a complicated formula. Like an example I'll give you here right now. If I have x cube 2x cube minus 5x squared plus 3x, you know, the big formula is gonna look something like this. So this shape is not like this anymore. Start to kind of jiggle and have two turns, one here and one here. The same thing for x to power 4. When you have it more complicated, x power 4 minus 3x to power 3 plus 7x. That's one, it's going to, it may look like this. It's like a W. Get more jiggly wiggly. For always the basics one, so they said plot this one. Well, because of the negative, remember that the odd numbers, the odd power, they look like this. This is x to power 5. The negative, we have to flip it. That's x to power -5. This one, still not that complicated. X to power 4, that's, it is positive. This being shifted to the left by 1. So your vertex is -1, 0. We learned that before. So the vertex at -1, 0. So if I have to draw it, the vertex is over here, and the function facing up because it's positive. Here we go. That's the shape it should be, look like this. Here we go. This is in they show us in the book how the x power 5 with a negative sign look like, and the other one x plus 1 to power 4. The vertex is as -1, 0. Leading coefficient test. We already know that from the parabola. We said if we have a positive x square, we say like that. If it's negative x square, it's like that. That's very similar here. Like if I have an x cube like this, then negative x cube like that. So from the sign, we know how the shapes look like. Here to give us a terminal, the general terms. If I have a polynomial of any order, so when they say an to power x to power n, you keep going until you reach a1x. It could be here a2x square. So it depends. It could be a line. It could be, it depends on n. N could be any number, 1, 2, 3, etc. If it 1 is a line, if it 2 is a parabola, if it 3 a cubic, if it 4, fourth order. However, here they are showing us when n is odd, we just talked about it, the shape is going to look like that in general, like inverted S or inverted Z. Okay. So n is odd and x and an greater than 0, positive. N is odd and an number is positive. That's we call the leading coefficient for the highest power. We don't care for any other power in the formula. We think about the highest power. And now, another possibilities, still n is odd, and an here less than 0 is negative, then this point here, it become here. Then we go like that, like this. So basically, it could be like this. It depends how complicated. Okay. For the even numbers of the power, n is even. And x to power, well, the an, the coefficient in front of the x, an positive, greater than 0, an greater than 0, then is facing up. It depends how complicated. It could be like this, it could be like that, it could be like this. It doesn't matter, you know. It depends on the power. Power 2, power 4, power 6. Now, n is odd, and n is even, still even. N is even, but an is negative, less than 0. Then the whole thing will flip. It's going to be facing down, facing down. It depends how complicated is the formula. Describe right-hand, left-hand behavior of the graph of each function. Well, let's go ahead and plot them. That's the easiest way, by understanding the formula. Well, this is negative. Remember, the x cube is like this. That's x cube. If you do negative, should be the other way. X negative power 3. So our shape, if it's not complicated, we don't know. If this is not too complicated, possibly is going to look like this. Okay, possibly. Or it could be like that. We need to plot it. One of those two should be look like. All what we do here, a prediction. That means we're coming from the negative infinity here and positive infinity on y, and going down, down, down into negative y infinity and positive x infinity. Now this one here is a positive x4, and the power is even, so this should be looking like w. It looked like more complicated. Definitely this looking like a w. If it's negative, then we flip, it become like an m. X to power 5, that's going to look like the original. Doesn't look very complicated. Could be like this, or it could be like this. And if it's a formula more complicated, it may be looking like that. But I don't believe it's going to look like this one, because this is not that complicated. Well, let's see the book what said. Yeah, that's the first one. We said we have two possibilities, so it seemed like this is enough complication, because the plus 4x make it look like a sided S. And the next one we said W. This one also like an S starting from the bottom. This is the positive directions. Remember the negative direction like that, because this here is positive. Real zero of polynomials. Well, we've been having x-intercept, and then we call this zeros. Now they call it real zeros. I mean, it's the same thing. All of them x-intercept. Here we still, every time we do, we say fx, set it equal to 0, or y equal to 0, then solve for x to find real zeros, to find real zeros. Real zeros like x1 comma 0, x2 comma 0, etc. Could be more than 2. XA, well, let's see in here. Let me go back. If we have a function, okay, any function, it have the largest power, x to power n. At the most, we're gonna get n real zeros. That's the maximum. We can get less. So the meaning is, if I have something x to power 3, that means I will have at most 3 real zeros. And the main reason is like that, because the function could be looking like this. And if you count how many interception with x, that's the maximum 3. It could be less. How come? If the function going this way, we have only 1 point. Okay. So the maximum is going to be based on n. If I have 4, maximum 4. If I have 5, maximum 5. If I have 2, maximum 2. So from the highest power, I can predict how many x-intercept possibly will I have. Well, if I subtract 1 from n, that would tell me how many turns I have in the function. So with the x to power 3, if I say 3 minus 1 is going to give me 2. Oh, it has 2 turns, 1 and 2 turns. So this is 1 turn and this is 2 turns. If x to power 2, how many turns? 2 minus 1 equal 1 turn. We know that parabola just have only 1 turn. All we need, why do we need this? What's the big deal about it? We need to, when we look in a function, immediately imagine how it look like, what possibly happened. We need to predict what happened. If I plot it, I make sure I plot it correctly. If we have a real zero, the way they are saying here, if I have a real zero, okay, like in here, remember we wrote x1 comma 0. Here they're saying a comma 0. So is a is the one for real zero. That means if x equal a, if a equals 0. That's the meaning. If a is equal 0. That's the function as the value a equals 0. And x minus a, it will be factor for that polynomial. I can factor it out. We're going to learn how to do that later, like by dividing. So this can be a factor of the polynomial. Find all real zeros. Yeah, well, this example, we solved it in chapter 1 when we looked for x-intercept. Those are the same things. So basically, you're going to say fx equals 0. You set the function, or you can say y equal fx equals 0. Then you find real zeros, which is x-intercept. So 0, we're going to say negative 2x to power 4 plus 2x to power 2 equals 0. So we set the entire function equal to 0. And the process, as we said before, we need to see if we have a common factor to factor it out, or any other method to factor the system. If I can see here, 2 is a common factor. X squared is a common factor. Let's see what's left. What's left? X negative x squared plus 1. Because the entire 2x squared is out, so I need to leave instead of it 1, that equals 0. Okay, that means here we have two solutions. Two solutions at this level. What are they? Because I wanted this equal 0. We know 0 multiplied by any number is 0. If this is 0, the entire thing is 0. Or if this 0, the entire thing is 0. So based on that, x squared equals 0. That means x equal 0. We say positive, negative, the answer. But this is 0. There is nothing about that, positive, negative. Basically, this is, to us, is a double. They call it double point. Double 0. What happened, 2 points, they become on top of each other. And normally this is a tangent. Or we have we have a tangent, like we have a horizontal line, will touch the graph at that point. Okay. Or we have a turn over here at this point. That's, I mean, best to say there is turn over here. There's a turn. Let's take the other one. Negative x squared plus 1 equals 0. Now, if I take the x squared to the other side, it's become positive x squared equal 1. X equal positive negative 1. So we have two answers here. So what the maximum number of intercept? There are 4. Max is 4 intercept, or 4 zeros. How many turns? 4 minus 1 is equal 3. 3 turns. So I know, so how does this look like? Because if this negative, that should be like an inverted M. That's the shape should look like. Okay, and you can see 1, 2, 3 turns. I'm going to have 3 turns. If I have, this is the x-axis, then I have 4 points of intercept. But I have 2, so let's see here. We have negative 1 comma 0, positive 1 comma 0, and we have 0 comma 0 double. We can, I can write it this way again. This is all zeros, which is really 4 points. But this is one, it look 1 point. Okay. So for that one to look 1 point, how is the graph should look like? It should look like this. If this is the x-axis, we have 1 point, 1 point, and this is the tangent to the x-axis. This is the 0, 0. And this is negative 1, and this is positive 1. See, before we do anything, we already know how it looks like. And this is a turn, as we said. So if I have to plot it more accurately, still, if I said this is 1 comma 0, I have here negative 1 comma 0, and we have here 0, 0. Then if I take my shape going up, turn 1 turn, then touch here, because this is double, I'm going to have a turn and come back up and go down. That's it. We plot it. In the book, they factor out the -2. It doesn't matter. To make it look like that, that's all right. I like it simpler. I factor it as a positive. Then because this is x squared minus 1, I can rewrite it as x minus 1, x plus 1. You don't have to do this. It's okay. You just say x squared minus 1 equals 0, then x squared equal 1, then x equal positive -1. You're going to get 2 answers. Here's the shape as we talked about. Here they are talking about repeated zeros. That's what we talked about, the double zero. Because I have x squared equal 0, we got double. Intermediate value theorem. Okay, let's understand the theorem before we say what is that for. This is x. And let's say we have a function y equal fx. If I have a point here, a, on x, the y value is fa by plugging in the a value. Now, if I have another point at x equal b, then the y value is fb. Now, if I pick up a point in between a and b, call it c. So c is greater than a and less than b. So if c in between, what's going to happen to the fc? Is it going to be above fb or below fa? Neither. It's going to be definitely in between. You can see that. So this is the fc. So basically, also, the y value at point c is greater or than fa, less than fb. Well, we can say equal fb. Okay, so that's the intermediate value theorem. They said if I have those 2 points A and B, and I picked up a point between them, the y of the C must be between the y's of the other two. So what's the big deal about this? We're gonna use it to find, like, if you have a polynomial and you don't know any zero yet, and you said, and you need to set fx equals 0, and it's a high order, like x to power 3 or x to power 4, and really pretty hard to factor it out, then the intermediate value theorem is going to help us. How? Let's try it again. This is x. And let's say we have a function like that. Now, we'll redraw it again. If I have a point here, this is a, and the fa is basically negative answer, negative fa, let's call it. Now have a b, and we find out the answer is in a positive y. So let's call it positive y. Now, you notice this function here, fx, intercept x in here. Let's call this point C. How much is FC? Well, because this is on X, does not have any Y, equals 0. So basically, if I have a polynomial and make a table and put a few numbers there, if the Y value change between negative and positive, then definitely there is a point in between that will give me Y0. So I have to try values. I'm going to say, I'm going to try this, I'm going to try that, I'm going to try this. I keep trying until I hit that point. Because if I try the other one, everything from here to here is going to give me negative answer. Everything from here to here, positive answer. So I'm going to go back and forth between positive, negative, positive, until I hit the 0. So basically, any graph, it was negative and kept going, it must cross the X at Y equals 0. Now, if it's going down, same thing, is going to have negative Y here. And so here positive Y, here negative Y. So we're going to have definitely a 0 here. Let's take an example. Please. Okay, let's do it here. Let's say I have fx equal x cubed plus x squared. Let me see what was the function. Plus 1. Find 1, 0 using intermediate value theorem. Find 1, 0. So what we're going to do, we're going to make a table. We're going to say here's x and here is fx. And the easiest thing to start with is a 0, because I don't know where to start. You can assume the value for x, anyone. So f0 equal 0 cubed plus 0 squared plus 1, that's equal 1. So what I got here, positive 1. Let's try another number. Let's say x is 1. How much is f1? 1 cubed plus 1 squared plus 1, that's equal 3. Well, I'm looking in the bottom now, I'm changing from positive to positive is not good. I'm looking for a negative number. Okay. And it seemed to me, because this is plus, 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 no matter what I do, if I go here 2, definitely I'm going to get 2 to power 3 plus 2 to power 2 plus 1. That's 8 plus 5 is 13. It's going to be positive. So every going this way is no good. So let's go. Normally I try to have one time positive here and go back here and say negative 1. Let's see what if negative 1 will give me. Negative 1 cubed plus negative 1 squared plus 1. Well, this one here is going to be negative 1. This is 1 plus 1 is 2. Oops, still positive 1. It's not working yet. Let's try the negative 2. F negative 2. Negative 2 to power 3. Remember, odd power will keep the sign, will not change it. Even power will make it positive. Negative 2 to power 2 plus 1. This one is equal negative 8 plus 4 plus 1. Oh, we got negative 3. Now, the y value changed from positive to negative, or from negative to positive. So somewhere in here, between those two numbers, I have 0. So what is the value of x? That's the deal. I have to make another table. X and fx, and expand this one, negative 2 to negative 1. Here I have negative 3, and here I have positive 1. So there is a method. You can try negative 1.1, 0.2, 0.3 until you reach negative 2. But that's very long way to do it. The easiest one, we use regression method. What is regression method? I start with the average of those two numbers, negative 1 and negative 2. Try x equal negative 2, negative 1 over 2. That gives us negative 1.5. Negative 1.5. Let's plug in. F negative 1.5 equal negative 1.5 to power 2, power 3, plus negative 1.5 to power 2 plus 1. Well, the solution is not in the book, so I don't remember the answer. Let me get my calculator. Here it is. And try to get the answer. So 1.5, right, x squared multiplied by 1.5. That is negative. Now, there's a negative sign. Okay, well, I multiply by minus 1 minus 1. That's negative 0.125. Okay, so that means, so now this is negative, this is negative. Then my answer should be in here, somewhere in here. I can do the average of those two numbers. Let's go back here. Try x equal Okay, equal -1.5 minus 1 over 2. That's give you 2.5. That's -1.25. And you have to do that until you get the answer. So if it, let me, well, let's see the exact answer for this problem. The exact answer for this problem, they said between -2 and -1. We already decided that. Really, if you look at it here, this is about -1.5. It's about that. You can see the answer we got was very small anyway. So basically, if you tried, instead of using the average, you can try -1.45. Let's go back. If I try, see, we said try -1 point, how much was it? 1.25. No, let me see. Let me do it again. 1.5 plus 1 divided by 2. 1.25. We said try 1.25. But 1.25 is gonna put me too far over here. So I'd rather try, see, kind of make, see, well, let's go back and try to tell you what maybe it's a little bit hard to understand, but let's try our best to understand it. So when we use -1.5, the answer -0.125, that's very close to 0. So I'm not gonna try the average here. How about if I took -1.45? Maybe this will hit 0, maybe, you know. So I know, so that's my guessing, because this is very -0.125, very close to 0. I don't want to go far away from 1.5. So let's try that. I will try it, see what I get. 1.45. Minus 1.45 x squared. Yep, I got -0.05. Well, that's okay. That I don't need it any more accurate. But 1 0 after the period is good enough. So that's the correct answer. So your 0 is -1.45, comma 0, roughly. We're gonna say it's approximate. Okay, so that's the method, guys. This is another example. They change the middle sign to negative, and they so you do the same process. You're making the table like they're showing here, and they say the answer between -1 and 0. I would rather expand it. Then they tried if -0.08, if -0.07. So then the answer between this and this. Well, we need to do the table. This is not, that is complete guessing. They are not telling us how did they get these numbers. The best thing to do, you go back. So when we did that table here, we have -2, -1, 0, and 1. So what we got when x equals 0, this is positive. When x equals -1, The answer is -1. So my 0 is between here. So whatever the x I'm looking for here is a 0. That's the reason I need to make another table. -1 and put 0 in here, because this is -1 and this is +1. Now I'm going to try first half x equal -1 plus 0 over 2. That will give me -1/2. So we're going to try -1/2 and see what happened. F -1/2, you plug it in, you say -1/2 cube minus -1/2 square plus 1. If you try that number, it's going to be positive number. Okay, then I'm going to try x equal -1 -1/2 divided by 2. That's giving me -0.75. Now we say f -75 equal -0.75 cube plus -0.75 square plus 1. Oh, this is negative here. Made a mistake. Let's do the calculator. I'm going to calculate this one this time. .75 x squared multiplied by 0.75 equal minus 0.75 x squared equal plus 1. Okay, I got the answer. The answer is negative. Oh no, I think positive. 1.5. Good. So on the -0.75, they gave me 0.015. That's a good answer. So 0.75 negative comma 0 is a 0. It's not too hard. You see, a couple of trials, we got the answers. Okay, in the books, they did tell us it's between -0.8 and -0.7. But with the method we use, we got it immediately -0.75. Okay, let's see if we have an exercise for you to practice. Module 2.2, maybe. Well, I already solved that one. We may have to, you can look at your homework. You must have one. Right now, this one is, I may have to change. I will change it later on. But we already solved that one. Okay. I will stop here.